Welcome. Let's consider any quadratic equation where the standard form is always ax squared plus bx plus c. And what we would like to discuss today is, would it be possible for us to rewrite that quadratic equation but using the product and the sum of the solutions of that quadratic? Any quadratic equation can be written using the format of x squared minus the sum of the solutions of x plus the product of the solutions. Well, when is this form useful? It is useful when we do not know the solutions, but we know a combination of the solutions. Let's put this idea in practice. Let's take a look at one example. So let's consider a quadratic equation. Let's try to come up with some equation where we have integer coefficients for the following scenarios. In scenario A, we want to make sure that the sum of the roots is equivalent to 11 and the product of the roots is equivalent to positive 28. Well, let's not forget that we have to find a format for that. A quadratic equation with this combination of its solution, it's going to have the form of x squared minus the sum of the solution, which in example A, it is equivalent to 11, plus the product of the solution, which in this case is equivalent to 28. And we are done. The equation x squared minus 11x plus 28, it will have two solutions, and we can guarantee that the summation of those solutions is equivalent to 11, and then in addition, the multiplication of those solutions is equivalent to 28. Let's graph this down, and let's show this result. So here we have our result, the equation x squared minus 11x plus 28. And notice that when we graph it, we obtain the following result. And here we can see that we have two solutions, one at the value of 4 and another one at the value of 7. We notice that when we add those solutions, 7 plus 4, it is equivalent to 11. And when we multiply those solutions, 7 times 4, it is equivalent to 28, which is the combination that we were looking for. Now let's take a look at example B. We are looking for a quadratic where the sum of the roots is equivalent to negative 3 and the product of those roots is equivalent to negative 40. So all we have to do, let's just plug it in to the form that we have defined previously. We're going to have f of x equals x squared minus the sum of the root, which we have a value of negative 3, x plus the product of the roots, which we have a value of negative 40. Let's just clean this up. Here we have the equation x squared, a minus times a minus, well, that is a plus. So we're going to have positive 3x, and a summation of a negative, that's the same as subtraction. We're going to get minus 40. And we are done. This quadratic equation, whatever solutions we have, I can guarantee you that the summation of the solution is going to give us a value of negative 3, and the product of those solutions is going to give us a value of negative 40. So let's grab this equation and let's confirm that result. So here we have the equation that we defined. Now let's graph it and notice the solutions, which are located on the intersection of the x-axis, it's equivalent to negative 8 and positive 5. Well, notice that when we add those solutions, we obtain the value of negative 3, and when we multiply those solutions, we obtain the value of negative 40. So we have satisfied the conditions that we are given. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.